Math 31, welcome to the last example in section 2.4. We're going to simplify powers of I for this example. And before we get going on all of A through F, I want to show you the pattern that presents itself when you're looking at powers of I. So let me just kind of square off a little workspace to show you the pattern that's involved here. And then we'll actually break down each of these problems. So when you're talking about powers of I, every fourth power loops on itself. And here's what I mean by that. If I look at I to the 0, right, we know anything raised to the 0 power is 1. Okay, so just keep that in mind. You know I raised to the first power is I. Anything raised to the first power is itself. We've talked for a while about how I squared is equal to -1. And I'm going to do a little algebraic manipulation here. I cubed, I think you'll give me it's I squared times I, right? We're going to buy into that. Well, I squared is -1, and -1 times I is -I. So I want you to see that through these first four powers, 0, 1, 2, 3, we went 1, I, -1, -I. And I want you to see that pattern, because it's going to play itself out again. So watch this. I want to go to I to the 4th. All right? I think you'll give me that I to the 4th times, I to the 4th is I squared times I squared. Well, what is I squared times I squared? That is -1 times -1, which is 1. All right, let me just space that out a little more. It's a little cramped. -1 times positive, oops, I already messed it up. -1 times -1, which is +1, okay? So I want you to see there was a 1 here, there's a 1 here, all right? Because I want to start to show you this pattern, this loop that powers of I have on themselves. So let's take a look at I to the 5th. I think you'll believe that I to the 5th is I to the 4th times I. What did we just say I to the 4th was? 1, right? So this is 1 times I, which is I. Right, so I think you're seeing I had an I here, I had an I here. All right, let's try I to the 6th. And before I write this out, try and think, I to the 6th, is it going to leave me with a 1, an I, a -1, or a -I? Well, I to the 6th is like saying I to the 4th times I squared. Well, I to the 4th is 1, I squared is -1, and I get -1. Right, I to the 7th. If I take a look at I to the 7th, that is I to the 4th times I cubed. So that is 1. We knew I cubed was -I. So this is -I. Right, so take a look at this pattern. 1, I, -1, -I. Right, and I could keep on going. We could go into, let me extend this. We could do I to the 8th. Right, I to the 8th is I to the 4th times I to the 4th, so that's 1 times 1, which is 1. Right, I to the 9th, I can write that as I to the 4th times I to the 4th times I, which is 1 times 1 times I, which is I. But I think you're starting to see the pattern as we go through here, right? All of these top levels are 1. This next level here, I. This next level here, you can tell I to the 10th is going to be -1. What is I to the 11th going to be? -I. There is always this looping. Every 4 powers, it loops on itself. All right, so let's try and figure out what on earth would I to the 33rd power simplify to. And we're going to do each of these the longer way. And then I'm going to show you a shortcut to help you. So if I wanted to think about I to the 33, let's see how many I to the 4ths that we can gather. Because I to the 4th is 1, just like I to the 0 is 1. But let's keep taking out 4 powers on this I to the 33. So you can imagine here, let me, again, I know I have a lot of things in boxes, but I can take 33, and that's 8 times 4, right, plus 1. Because 33 is ultimately 32 plus 1. So I can rewrite this. Actually, let me put this in a slightly different spot. Okay, let me erase this and put it off on the margins. Okay, so I could say here, right, I'll put it here. So 33 is equal to 8 times 4 plus 1. All right, And the reason I want to say that is because this is equal to I to the fourth times I to the fourth times I to the fourth. I got to write 8 of these. Give me a moment. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, and then finally I, right? So 4, 8, 12, 16, 20, 24, 28, 32, 33, right? This is I to the 33rd power, but all of these I to the fourths are 1. So ultimately I have 1 times 1 times 1 times I. My answer is I, okay? Let's think about 29. 29, if I think about the number 29, I know 29 is 7 times 4 plus 1. So this would be I to the fourth times I to the fourth times I to the fourth times I to the fourth. Give me a sec. I got to write 7 of them. I think I have it. 1, 2, 3, 4, 5, 6, 7 times I. So ultimately all of these will turn into 1 and I get an I. Okay. Now the thing that 33 and 29 have in common is that when you divide 4 into them, their remainder is 1, right? So if I divided 4 into 33, I would get 8 and I would have a remainder of 1. And if I took 4 and I divided it into 29, I would get 7 with a remainder of 1. Right? And whenever you have that remainder of 1, you will be on this first level here, right? Anything to the first power is just going to be I. Well, not anything, but I to the first power is I, okay? So how this will work is you'll take your power, whatever it is, divide it by 4 and see what the remainder is equal to. If the remainder is 0, your end answer will be 1. If the remainder is 1, your end answer will be I. If your remainder is 2, your end answer will be -1. And I'll squeeze this in here. If your remainder is 3, your end answer is -I. So let's keep that in mind. And these powers are written at the bottom of the paper in case you need to see them. But let's take that into consideration with example 9c. So this would be, if you remember negative exponents, that's like saying 1 over I to the 14th, okay? Now, if you want, you can write this out the long way. I don't recommend it. You can say this is I to the 4th times I to the 4th times I to the 4th, wait for it, times I squared. So this is 1 times 1 times 1 times -1. So this is ultimately 1 over -1, which is -1. So you could do it that way. That's totally fine. Now I'm going to, instead of doing that, I'm going to go ahead and divide 14 by 4. Let me make sure you're going to have enough room to see this. So if I take 4 and I divide it into 14, I get 3, remainder 2. Right? And anything with a remainder of 2 means that I should be ending up with an answer of -1. Right? So I would have had 1 over -1, which is -1. All right, so with that, let's try it here. This is 1 over I to the 12th. And if I take 4 and divide it into 12, I'm going to get 3, remainder is 0. If my remainder is 0, this is ultimately going to be 1 over 1, which is just 1. Right? Now, again, I could have written this out as I to the 4th times I to the 4th times I to the 4th, but what's the point? Once you start using the remainder, you can just zip through these pretty quickly. So with that, let's go ahead and try parts E and F and see where we wind up. So I'm going to scooch this up just so we can see our remainders of I pop in one more time. Okay, so let's try this. If I have 1 over I to the -12th, that's like saying I to the 12th. Okay, so let's see what we have. I'm going to take 4, divide it into 12, I get 3, remainder 0. Anytime there's a remainder of 0, my answer is just 1. All right, let's try it with 39. So if I take 39, divide it by 4, I'm going to get 9, remainder 3. Anytime my remainder is 3, my answer is ultimately -I. All right. Now, again, if you wanted to, I wouldn't recommend it because it takes a while. You could have written this as I to the 4th times I to the 4th times I to the 4th. I got to do 9 of these. And then you would have had an I cubed left over. All of these go to 1. You know I cubed is equal to -I, so you could get -I. But I would still go with the remainder method. It's faster, just takes a lot less work, it's cleaner. All right, so with that, we finished out section 2.4. We will start looking at quadratics in section 2.5. Thanks, gang. Bye.